Hello and welcome to this first in a series of ESP32 design pattern videos. Design patterns are an essential part of building reliable and efficient ESP32 projects and can cover hardware-software integration, power management, and IoT connectivity. In this video, we will look at a design pattern for integrating hardware timers into task synchronization. Let's take a look at what we'll be covering. In this video, we will be looking in detail at a design pattern for task and timer synchronization, how to initialize multiple timers, how to use a timer callback to trigger a task, and how you might use the task, for example, to sample sensors. In my IoT project, my ESP32 device is required to read several sensors at different time intervals. For example, a temperature and humidity sensor every 5 minutes, a barometric pressure sensor every 15 minutes, and a light intensity sensor every 10 minutes. In my project, the data is sent across my MeshLite network to the root node where it is stored on an SD card. What I needed was a single task that could read the sensors and then store the data temporarily locally. A separate task manages the data transmission to the mesh root node. Why use timers? Timers are more accurate than, say, for instance, the V-task delay method. The ESP timer uses a high-resolution hardware timer to trigger callbacks with a 1 microsecond precision. Delays can introduce a cumulative drift because the work done in the loop adds to the total cycle time, and timers will always run at the specified periodic interval. Timers are useful for efficient power management, and in light sleep mode, the ESP timer hardware will automatically wake a timer. Timers are also useful for efficient memory management. Multiple timers run from a single high-priority timer task. If I could ask you to leave a like on this video, and if you haven't already and you enjoy this channel, to hit that subscribe button. It goes a long way to helping this channel develop and really does mean a lot to me. In this design pattern, 3 timers and a task are configured. In this example, it assumed there are 3 sensors to be read, 1 timer for each sensor. The timers trigger a callback method every 20, 30, and 40 seconds respectively. An event group allows the timers to synchronize with the sampler task. The sampler task waits on 1 or more bits to be set in the event group. Each timer is assigned a unique bit value which is used to set a bit in the event group. There are 3 bit values and a bit corresponds to a single sensor. On configuring a timer, the appropriate bit is assigned to it as a callback value. When a timer triggers, the bit read by the timer callback method, the method sets this bit in the event group, and this causes a sampler task to resume execution. The sampler task checks the bit value to determine which sensor to read. This sequence diagram illustrates the 3 timers and the sensor sampler task. The sampler task waits for a bit to be set in the event group. When a timer is triggered, it sets the event group bit which causes the sampler task to resume, and depending on the bit value, the relevant sensor will be read. I have developed this code using the ESP IDF version 5.5.2. My development IDE was VS Code with ESP IDF extension. My ESP32 variant was an ESP32 with external antenna. Now let's take a look at the code. This code snippet shows the event group bit values that are assigned to the timers and which are used to communicate with the task. The timer callback receives a callback argument which is the bit configured when the timer was created. It sets this bit in the task event group. The 3 timers are created in this code snippet, 1 for each of the sensors being sampled. The sampler task starts and then waits immediately on an event group bit to be set by the timer callback. On receiving a bit, it figures out which timer was triggered and then samples the relevant sensor. This code snippet shows the app main method, which initializes the timers and sampler task. This log trace illustrates timer triggering and sampling of the relevant selected sensor by the sampler task. There is a lot more that can be done with this code, and the code presented here can be used as a framework for the following exercises. After sampling a sensor, store the data. Secondly, synchronize the sampling task with another task that processes the sensor data in some way. Use a semaphore, mutex, event group, queue, or task notifications. Well, we're just about done with this video. I hope that you found this video useful and that it helped you understand this typical design pattern and that you'll use it in your projects. I hope that you'll consider pressing the like button and subscribing to the channel. These actions really do help the channel develop and reach more ESP32 developers. And if you'd like access to the source code and circuit designs for all of my projects, then why not become a channel Patreon member? Please see the link in the description. I post videos regularly, so I'll see you in the next one. Thank you and bye for now.